In these videos, we will discuss the next subject for your GATE perspective, that is the internal combustion engine, right? IC engine is the application part of the thermodynamics, and if you see the syllabus of the GATE 2021, which is now released by the IIT Bombay, so we can say that in the internal combustion engine, that this topic internal combustion engine is added in the application part of the thermal engineering, that is the application part of the basic thermodynamics. And the syllabus of the internal combustion engine, if we talk about only as per the GATE perspective, we have to study only the air standard cycles, that is the Otto cycle, diesel cycle and dual cycle. These three topics are only in the syllabus of GATE. If we talk about the syllabus of engineering services, then in the engineering services, the syllabus is wide. The vast syllabus of IC engine is there. We have to study the combustions, we have to study the you can say that pollution, air emission, spark plug, ignition systems, cooling systems, and load calculations. We have to study a lot if we talk about the engineering services. But for the GATE, only three cycles, Otto cycle, dual cycle and diesel cycle will be there from the internal combustion engine. And if your thermodynamics concepts are good, if you are good with your thermodynamics, then you will be easily able to go with this IC engine. And if we talk about the weightage of this IC engine in the GATE, so hardly 1 or 2 marks question will be there, because only 3 topics are there. So maximum 2 marks question will be there. Generally only 1 mark question will be there in the GATE paper, or in sometimes in some of the papers not even a single question will be asked from the IC engine, right? We will cover this topic just because if some question will come of 1 or 2 marks question, and that question will be a scoring that will decide your rank, right? That one question will decide your rank. That is a very scoring subject, very easy subject. Only 3 cycle you have to study, and basic 3 cycle you have to study. So that's why we are covering this IC engine, right? Now we are only covering as per the GATE perspective. Later on we will add some more videos as per the engineering services perspective, right? So theory part of this IC engine, some theory is there. What is the basic definition between internal combustion engine and external combustion engine? What are the various classification of the IC engine, like your 2-stroke engine, 4-stroke engine, and your SI engine, that is spark ignition engine, compression ignition engine. All these theory we will cover separately, but in these videos we are covering the numerical part, the cycle part, from where the question will come. We are only covering this as of now, but we'll upload the videos on the theoretical part also, that just to have a basic understanding of the subject, right? Just for now, which is required, I'll say here internal combustion engine, right? Engine, as the name suggests, that engine means that a work producing device in which you will get some work, right? So engines are of 2 types, or you can say that power cycles. These are the power cycles. The power cycles are of 2 types. One is the external combustion engine, another one is the internal combustion engine, right? In any power cycle we have 4 processes. If we talk about, first we have the suction, right? Suction of the, or you can say first suction of the mixture, that will be air or fuel or steam or diesel, petrol, any fuel which is the working material. So first we suck that material. Then the first process is compression. We will do the compression of that. Then we have heat addition. After heat addition we have the power process, that is the expansion process. After the expansion process we have exhaust process, right? These 4 are the basic process. First compression, heat addition, expansion and heat rejection. These are the 4 processes which constitute any power cycle. In any power cycle we will study some power cycle in the power plant, where we have gas turbine cycle, vapor power cycle, right? So we have to discuss those also, right? In every power cycles these 4 processes will be there: compression, addition of heat, expansion and rejection of heat. these four process will take different types, right? There may be a constant volume heat addition, there may be a isobaric heat addition, right? There may be a constant pressure heat addition. Based on these changes in the types of process of these four process, the nature of these four process, different cycles will be there which you have to study, right? So the basic difference between internal combustion engine and external combustion engine is that, as the name suggests, it is internal combustion, means that the combustion will be in the system, inside the system. If you see from the case, if you see that your engine of your automotive, right, engine of your automobile, your car engine, then in the car engine the burning of the petrol or the burning of the diesel will be inside the engine only, inside the system only. So in the cylinder head the combustion will be inside. So that type of process, all the other three process, heat addition, expansion and heat rejection, right, sorry, compression, expansion and heat rejection, these process will be in the cylinder itself, but the difference between the heat addition. So in the internal combustion engine, heat addition will be inside the engine only. That means the combustion will be inside the engine only as your locomotive, as your automobile engines, right? But in the external combustion engine, if we talk about the external combustion, the combustion of the fuel will be burnt outside the engine. For example, your thermal power plant, for example, your steam power plant, steam power cycles. In those cycles, the fuel will be combust, the fuel will be burned outside the cycle. Now if we talk about steam, we will generate the steam somewhere else, then we took that steam to the turbine. In the system we have turbine, we just make that steam which is prepared somewhere else, that steam will be taken to the system, and then we strike it on the turbine, and then turbine rotates, and then you will get the power or you will get the electricity. That will be the process in external combustion engine. So this is the basic difference between external combustion and internal combustion engine. So we have to discuss, in this case we have to discuss internal combustion engine. External combustion engine we will discuss with the power plant, where we will study your steam power plant and gas power plant, right? That will be on the Rankine cycle and Brayton cycle, as you all know, right? We have to discuss that also, that is also in the syllabus of GATE, right? So as I already said that we will cover in these lectures, we will cover the application part of the internal combustion engine. Theory we will cover it separately with the help of some presentations, with this help of some PPTs we will cover theory separately. Those videos will also be there for your basic understanding of the subject. Now let us move to the analytical part of the IC engine. Before moving to the thermodynamic analysis or the analytic part of the IC engine, let us define some of the assumptions which we have to take during the analysis. We have to take these four assumptions during the analysis. The first assumption in thermodynamic analysis of IC engine is assumed to be a closed cycle. We are assuming that the engine is a closed cycle and there is a fixed mass of air inside the system, and there is no chemical process, there is no chemical change of that air will happen during the process, during the complete cycle. Generally, if we talk about generally, that the IC engine or any engine is not a closed system, right? Because air is coming, mass flow rate is coming, petrol is coming inside the engine from the surrounding, and the exhaust gases through the silencer, that exhaust gases are going out of the system. It is not a closed system, but during our study we will assume it as a closed system with a fixed mass of air. That air is inside the system and there is no chemical change of that air, right? During the heat addition or heat rejection, there should not be any chemical reaction taking place between the air and some other fuel, so that will not be the case, right? This is the first assumption. Second one is the combustion process is replaced by an equivalent energy addition process from an external source, right? We will say that the combustion process will replace with some equivalent energy addition process just like your constant volume process or constant pressure process. So these type of process we can assume that the heat will be added in this engine in this process. During this process, let us talk about Otto cycle. So in the Otto cycle, the heat addition will be at constant volume. So we will assume that the combustion process is the constant volume process, right? So that is replaced by an equivalent energy addition process. Similarly, the exhaust process is replaced by an equivalent energy rejection process to the surrounding, right? We will say that the heat will be rejected outside to the system by an equivalent energy system. Generally, how the heat will be rejected in your automobile or in your car, if we talk about that, there is some inlet outlet valve. So when the heat rejection process is started, then outlet valve will open, then the gas will goes out of the system. So if we consider these type of the process, then the system will be a closed system, not the open system. Sorry, the system will be an open system, not the closed one. But we have to analyze the IC engine based on the closed system parameters. So we can say that the exhaust process, suppose 100 kilojoule of energy is going out, or the air, the gases, the burnt gases, the residual gases which are going out through the silencer from the engine, they take 100 kilojoule of energy during one cycle. So we will assume that there is an equivalent process, which is suppose a constant process, a constant pressure heat rejection, which will reject the same 100 kilojoule of energy from the system to the surrounding, right? Without considering that the air is going out of the system, because we considered it as a closed system. That is important, right? So this is the third assumption. Fourth assumption is obviously that air is assumed to be as an ideal gas. We assume that air is behaving like an ideal gas with the constant specific heats. The specific heats at constant volume and specific heat at constant pressure will be constant. They will not change with in the process with the temperature or with some any other thing. They will not change. We are assume that Cp, V and Cp, Cv and Cp will be constant. We are assuming it, and that is known as cold air assumptions, right? These are known as cold air assumptions. And if this air is assumed to be an ideal gas, so that's why all these cycles which we have to study now, that is Otto cycle, dual cycle and diesel cycle, all these three cycles are also known as air standard cycle, because in that case air can be standardized as an ideal gas. So these are also known as air standard cycle. So these are the four assumptions which we have to take care of while solving the thermodynamic analysis of the IC engine. Now let us picturize some important points which I want to share with you. Is suppose this is a cylinder. Suppose this is a cylinder and piston is moving in this cylinder. Piston is moving in this cylinder, right? This is the cylinder head. Top portion of the cylinder is cylinder head. This complete assembly is cylinder. This is cylinder. And a piston is there which is connected with the piston rod, that is connected with the connecting rod, and that is rotating, and the piston is sliding or translating inside this cylinder head, in this cylinder you can say. So obviously that the piston will not touch this cylinder head. We make such design that the piston during its motion, during its translation inside this cylinder, it will not touch this cylinder head. Otherwise the valves, here we have some valve, inlet and outlet valve. In the spark ignition engine we have one spark plug here. So if the piston is touching this cylinder head continuously at a very high speed, if that is touching the cylinder, then it will exert a impact force. Suppose this is a cylinder, and if this piston is striking this cylinder again and again, this is a very slow speed, because piston is moving very high speedily, very high. With a very high speed, if it is touching the cylinder continuously, it will exert an impact force on the cylinder, and it can damage the inlet and outlet valve which is present here. One spark plug will be there. Any other instruments will also be there in the cylinder head. They can damage if this piston is touching the cylinder head. So let us say that we designed it. Suppose the piston, the highest position of the piston is this one. This is the highest position of piston. Piston will go up to this level only. It will not touch the cylinder head. The piston will go up to this position only. This is known as highest position of the piston. And in the case of vertical cylinder, this is a vertical cylinder in which piston is moving like this. We have another case of cylinder also. We have another case of engine, which is your horizontal cylinder, in which we have horizontal cylinder in which piston is moving like this, right? Piston is moving like this. So in the case of vertical cylinder, this highest position is known as TDC, that is top dead center, because it is in the top. This is top dead center. In the case of horizontal cylinder, if this cylinder is horizontal, when the piston is moving like this, it is known as IDC, that is inner dead center, right? Similarly, we have the lowest position of the piston. This is the lowest position of the piston. So piston will only reciprocate between this top dead center, and this is known as bottom dead center in case of vertical cylinder. And in case of horizontal cylinder, it is known as outer dead center. ODC is outer dead center. So the piston, during its motion, during all the process, the piston will be rotating, the piston will be reciprocating between this TDC and BDC. This piston will be reciprocating between this. And the length covered during one motion from here to here, this one length is known as stroke length. This one length is known as stroke length. From here to here, when this length is known as stroke length, let us say L, stroke length, right? So the distance covered by the piston in one stroke length is this one. This one is the distance covered, and the volume covered during this one stroke, volume covered matlab means, if we can say the piston is coming from here to here or from here to here, when the piston is coming, this volume which it covered, this volume is known as stroke volume or swept volume, which is denoted with the letter Vs. Swept volume means the volume is swept by the piston. Between this top dead center and bottom dead center, the volume is swept in one stroke, that is known as swept volume or stroke volume. And this portion, this space between the top dead center and the cylinder head, this space is known as clearance. This much clearance we give so that the valves or the spark plug or the carburetor connections, that will not be damaged because of the heating, continuously heating. So this volume is known as clearance volume. This volume is known as clearance volume. This volume is known as clearance volume, right? Between the top dead center and the cylinder head, right? We have now will define a term that is known as clearance ratio. Clearance ratio is this clearance volume upon swept volume. Clearance ratio is denoted with the letter C. It is the ratio of clearance volume upon swept volume, right? Clearance volume upon swept volume. Now, suppose if I can say, during the compression is going on. So let us say this is the starting position of the compression. Let us say this is 0.1, and let us say this top dead center is 0.2. This is 0.2, right? So let us say here with this volume is V1 and here we have volume V2. Now let us see, just imagine the things. When piston is here, right? Suction stroke already completed. We assume that suction is completed. The complete air fuel mixture is present in the cylinder. Piston is here. So the volume occupied by the air fuel mixture is this complete volume, that is V1. At point 1, the volume of the cylinder, the volume inside the cylinder is V1. As this piston will move in the upward direction, the volume will decrease, and when the piston will reach its highest limit, that is the point 2, that is the top dead center, then at this point when the piston is here, then the volume occupied by the gases or the volume occupied by the air fuel mixture is this V2. this volume, this clearance volume V2, right? So from here, what I can write? From here I can write that V1 will be equal to, how much is V1? V1 is the volume of the air fuel mixture or the system volume. V1, we are defining the system volume. This is complete, this complete is our system. Inside the air and gases, this is our system. So this at point 1, what is the volume of the system? That is this complete volume. This complete volume will be equal to this swept volume plus this clearance volume. Swept volume plus clearance volume. And now what is V2? V2, the volume at point 2. Volume of the system at point 2 will be equal to clearance volume. The volume is equal to clearance volume. Then we will define a term that is known as compression ratio. Compression ratio during the compression process. Compression ratio denoted with the letter R. This is for compression process we are writing. Compression process. When the air fuel mixture is compressed with the help of piston. So compression ratio R, that is equal to, this can be defined as V1 upon V2. Compression process is from 1 to 2. You can write like this, from 1 to 2. So R will be equal to V1 by V2. And obviously V1 is more than V2. So this will be greater than 1. Compression ratio is V1 by V2. Right? So we can write from here R will be equal to, what is V1? Swept volume plus clearance volume divided by clearance volume. This will be equal to swept volume upon clearance volume plus 1. What is this? Vs by Vc, 1 by C. So from here you can write R will be equal to 1 by C plus 1. So from here you can write that compression ratio will be equal to 1 plus C divided by C. Compression ratio will be equal to, you have to remember these terms, because if the question come from the IC engine, then it will not be a very difficult or a lengthy question. You can solve it very easily. So just you remember these formulas. So the compression ratio will be equal to 1 plus C divided by C. 1 plus C divided by C. Right? So this will be the compression ratio. Now let us move towards the different types of cycle which we have to study. We will start with Otto cycle, then diesel cycle, then dual cycle.